miss you guys. I made you guys this video to kind of review for your mini quiz, mostly because I'm so thankful for all of you guys, and I thought it would be nice for you to have a little extra review if needed. So I'm going to go through problems on worksheets 2 and 3. I've already recorded this, and I want to warn you that there are some baby cries. He's actually, I think, trying to go to the bathroom right now, but this is Louis, and he is an angel, but he did cry during some of this recording, so my apologies, but it is what it is. This is maternity leave, lots of baby cries, and taking care of this little one, but I squeezed in this video just for you guys, so enjoy. I miss you guys. Hey, class. It's Mrs. Scott, and I am here to do some examples from worksheet 2 that are similar to mini quiz problems. So I am just going to start right away with number 1. Again, this is worksheet 2. So for number 1, it says explain how y equals 5 times the absolute value of x minus 7 plus 9 is then translated from y equals absolute value of x. So this is our parent function, absolute value, and as you guys have learned, there's a few things going on. We have some horizontal and vertical shifts. So this function has moved to the right 7. So inside we go left or right, and it's the opposite as the sign. So if it's a minus 7, that moves right. This is also moved up 9. So outside moves the function up or down. And you don't have to do the opposite thing like you do when the number's inside the function. And then last, there's one more thing that happened, and it's this 5 out in front. So this is a vertical stretch. And that would be a 1-month-old baby in the background. Okay, buddy. I thought you promised me you'd be good right now. Okay. Shh. All right, so, oh man. Sorry guys, he was just sleeping so well. Okay, so that is a vertical stretch of a factor of 5. So what I want you guys to know about that 5 out in front is that it's actually going to affect the y values. So you would take all the original y values with a parent function and multiply those by 5. And I'm going to give you an example of that when we're graphing, okay? So let's move on. The next one I want to do is number 3, and instead of doing A and B, I'm going to do C because C is kind of a combo of A and B. So there's a lot going on with that. So if I have an original function, f of x, oh, it asks for the corresponding points. I didn't even realize that, but let me show you how I would do this problem. There's a lot of things happening. So this out in front is always going to affect the outside stuff, always affects the y values. So this is going to be my y values times negative 1/3. Now the negative actually flips the function upside down. That's called a reflection. But when I'm dealing with just ordered pairs, you can group the negative with the number out in front and just multiply your y's by that. But again, what's happening, there's a reflection over the x-axis. There is a vertical stretch of a factor of 1/3, and then there is also a horizontal shrink. But really all you have to know about this one is you have to multiply the x values times 1/2. Now let me talk about that for a second. Technically what's actually happening is it's technically the x's divided by 2. Is technically what's happening. So what I want you guys to think about is anytime something is inside of the function, you're actually going to do the opposite of what's happening. So this is 2 times x. What's actually happening is all of my x's are being divided by 2. But when I divide by 2, it's the same as multiplying by 1/2. So a lot of the times teachers are going to explain, well, you just multiply by the reciprocal when it's inside. What I like to do is remember, oh my gosh, and now my doorbell's ringing. There's so much going on. What I like to remember is that technically it's always opposite. So if it's 2x, then really my x's are going to be divided by 2, which is the same as multiplying by 1/2. Okay, so let's take all of these facts and let's work with our x's and y's. So the first point is 4, -3. So the x value is 4, and I have to divide that by 2, which is the same as multiplying it by a half. So that's going to go to the number 2. My y's I need to multiply by -1/3. So 3 times -1/3 is just +1. -3 times -1/3. So this point is now 2, 1. Okay, second point. Cut the x value in half. So divide it by 2. That's going to be -1. And 0 times anything is 0. Okay, buddy. Okay. All right, one more. And then I'm going to have to pause this and take care of the baby. I'll be back after that. So then x's we cut in half. So that's going to be -5. And my y values, I'm multiplying by -1/3. So let's see, the negative times negative will be positive, and that's going to be a 5. So there's my 3 new points. Hopefully that makes sense. I'll be right back after I take care of this child. All right, so I am now going to do some of these graphing problems. I'm going to try to do one of each kind of graph. There's Louie again, just making he needs to be part of the action. So it's okay, buddy. I'm going to try to do one of each kind of graph. Okay, so starting with number 9. I am going to do the step function one, but I'm going to do a different one. All right, here's the deal. This is a cube root graph. So just as a reminder, I would memorize those. I call them quick points, but it's the original points of the parent function. So for the original function, this is the cube root of x. So the original points of this function, the x values are -8, -1, 0, 1, and 8. And then the cube root of each of those, so -2, -1, 0, 1, and 2. These are my original parent function points, okay? So you might be like, how did she get those? They're memorized. Really, I just pick numbers that I'm able to cube root, and then I cube root them for my y values. But all in all, this is the parent function, okay? And I'm going to take those points and I'm going to move them. Essentially, that's what I'm doing. The translation here is that this function is going to go up 3, but it also has a vertical stretch. So my y values are going to be multiplied by 2. And then they're going to be shifted up 3 because up and down movement changes my y values. So instead of just thinking about the graph and trying to figure out that stretch, I like to just take my original y values and do math to them. So do the arithmetic. I'm going to multiply all of these by 2. That's because of this 2 out in front. So that will become a -4, a -2, a 0, a 2, and a 4. But then I have to move them up 3. So I'm going to take those and I'm going to add 3 to all of those. So -4 plus 3 is -1. -2 plus 3 is 1. 0 plus 3 is 3. And 2 plus 3 is 5, and 4 plus 3 is 7. So these are my new y values. And my x values, nothing changed. So I'm just going to plot these points. So -8 is at -1. -1 is at 1. 0, 3. 1, 5. And finally, 8, 7. Beautiful. So this goes, it's kind of like a snake. I know, buddy. There we go. Beautiful. Glorious. All right, so that is my cube root function. Let's move on to number 10, which is an absolute value function. I do this one a little bit differently. I don't usually do these original parent function points like I do for most graphs. For this one, I just like to use the fact that normally the absolute value function begins at 0, 0 and has a slope of 1 on each side, up 1, right 1, up 1, right 1, and then technically the slope is -1, up 1, left 1, up 1, left 1. So I use those facts to kind of graph each absolute value function, starting, come on, buddy, come on. Oh, man. All right, let's finish this graph and we'll pause. Thank you. All right, so starting with the horizontal and vertical movement. So this graph is going to move left 2. Again, I take that inside plus 2, and it's going to be the opposite. So left 2 and up 1. And then the negative in front, instead of the V going right side up, it's just going to be flipped upside down. That's what the negative in front does. Come on, buddy. All right. I know. Come here. I'll pick you up. Come here, buddy. Shh. Okay, so left 2, up 1 is my new vertex. Come here. Come here. Left 2, up 1. That's my new vertex. And now instead of going up 1, right 1, I'm just going to go down 1, right 1. So it's just going to go down instead of up. And the slope is 1 on each side. Wow. Well, this video is a disaster. So that's great. All right, so this is the graph. I'm going to have to pause, and I will be back after I take care of this munchkin. Come here, buddy. All right. Okay, this next graph is a quadratic, and it's a quadratic because it's the quantity being squared. And again, I use a different strategy for this one. Instead of using the original points, you can use the original parent function points. I like to call those the quick points, and transform them. Or you could use the 1A, 3A, 5A strategy, which is, I know, something you guys talked about in class. So that's probably the route I would go. So with that, the vertex, which is usually at 0, 0, and then usually from there we go up, left 1, up 1, right 1, up 1. That's the 1A, and then up 1, 2, 3. That's the 3A, and then up 5 from those points. So that's the 1A, 3A, 5A in the original function. But if the original vertex is at 0, 0, then we are going to take that and we are going to move it right 3 and up 7. Okay, so the right 3 is from the inside and the up 7 is from the outside. So if I move right 3 and I move up 7, that's right here. And that's my new vertex. So from there, I'm going to do 1A, 3A, 5A. The A is -2. So I'm going to take the numbers 1, 3, and 5 and multiply them all by -2. Okay, so that's going to be -2, -6, -10. Again, 1 times -2 is -2. 3 times -2 is -6. 5 times -2 is -10. The negative indicates that we're going down instead of up. That's it. There's been a reflection. So from my vertex, I'm going to go over 1, down 2 on both sides. From those points, I'm going to go over 1 and down 6. 1, 2, 3, 4, 5, and 6. And that'll be mirrored on the other side. And from those points, I would go over 1 and down 10, but that's not going to fit onto my graph, so I'm going to stop here. Beautiful. And beautiful notability will make me a beautiful, nice parabola. Okay. And here we have our arrows. Okay, so that is number 11. Moving on to number 12. This one is a cubic function. So if you want to use the parent function points, you can. The parent function points are just the opposite of the parent function from the cube root. They're literally switched. -2, -1, 0, 1, and 2 are my x values. And my y values, just take all of those x values and cube them. So -8, -1, 0, 1, and 8. Are you grunting? Okay. All right, so those are the original points, but we're going to take all of these points and we are going to move them left 5. So I could physically just picture the, original graph and then take that and move it left 5, or I could take all my x values and I can take them and move them left 5. So if I take -2 and move that left 5, it's going to move to -7. I'm really just subtracting 5. That would move to -6. 0 minus 5 is -5. 1 minus 5 is negative 4, and 2 minus 5 is negative 3. So these are my new x values, and my y values are going to stay the same. So negative 7 is going to be at negative 8. Negative 6 is at negative 1. Negative 5, 0. Negative 4 is at 1. And negative 3 is at 7. So this kind of is like a snake going up instead of side to side. And there you have a beautiful cubic function that's been moved left 5. Okay. I'm going to skip 13. I'm going to do a square root function on number 16, so just to save time. Let's talk about the step function. So this step function, the original step function, starts with a filled in circle on the origin. It's 1 unit long, and then an open circle, and then it jumps up 1 unit and it repeats. That's the original step function. We are going to change that. So if there is a number that is inside that's being multiplied to the x, that changes the length of the step. And it's the opposite. So instead of the length being 2 units long, it's actually, you have to divide the length by 2. Again, like we talked about, since it's 2 times x inside, you're actually dividing by 2. So the length of the step is actually going to be 1/2 unit long instead of 1 whole unit long. And then we are going to also shift these up 1. So if the original starts at 0, 0, then I'm going to shift it up 1. It's now going to start up at 1, and the length of the actual step is just 1/2 of a unit instead of 1 unit. And then I'm going to jump up 1 and repeat. Jump up 1 and repeat. It's just 1/2 a unit long. Jump up 1, repeat. So you might be thinking, well, when do you jump up 2, for example, instead of just jumping up 1? That's if the number's out in front. Okay. So there we have it. Oh, it's okay, buddy. Louis just ate, so he's just digesting. Okay. So you'll have to excuse his grunts. All right. So just to save time, there you have your step function. We're going to skip to number 16. This is a square root function. This is one that I would do the parent function points. So for a square root, the parent function points, let's see, I can't have any negative x values because you can't square root a negative. So it's 0, the square root of 1 works, the square root of 4 works, and the square root of 9 works. Those are my x value. And the parent function is just square root of x. So the square root of 0 is 0. These are my y values. The square root of 1 is 1, the square root of 4 is 2, and the square root of 9 is 3. These are the parent function points. So now I'm going to take these and I'm going to do something to them. So let's see, my x values are all going to be shifted left 6, which means I'm just going to subtract 6 from each of these. So if I take 0 minus 6, I get negative 6. 1 minus 6 is negative 5, 4 minus 6 is negative 2, and 9 minus 6 is 3. And for my y values, I'm multiplying them by 3. So 0 times 3 is 0. 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. If you're thinking, why did you do that? Because of this 3 out in front. That 3 is being multiplied out in front, which means I take my y values and I multiply them by 3. And I'm just going to plot my new points, which are these points. So negative 6, 0. That's right here. Then we have negative 5 at 3. Negative 2, 6. 3, 9. And that's off the graph, so we won't do it, but we know that it's there. Okay, so that is my square root function using the parent function points and just transforming them. Okay, it looks like I'm going to do 17. I mean, 17 is very similar to number 12, so I I don't know that I need to do that one, but really you're just going to be taking your original cubic function. I guess I'm doing it here. -2, -1, 0, 1, and 2. And the original points will be -8, -1, 0, 1, and 8. This is the parent function points, and I'm taking them and I am moving them right 5. So that means I'm going to add 5 to my x values. And I'm going to also move this down 1, so I'm going to subtract 1 to my y values. And then I'm going to plot my new points. So 3 is at -9, that's off the graph. Let's skip to 4, -2. For -2, 5 is at -1, 6 is at 0, and 7, 7. Oops. Oh, let's try that again. There we go. That way and this way. Beautiful. Okay, last but not least, and this is a quick one, this is an absolute value function. I just want to talk about what that 4 out in front does for absolute values. So again, I would just plot the vertex. So this vertex is right 5, down 6. Right 5, down 6 is right here. The 4 out in front just changes the slope of the absolute value. Usually we go up 1 over 1 on each side for the slope of each side of the absolute value. But the 4 just changes the slope. So think of like rise over run. 4 is 4 over 1. So I'm going to go up 1, 2, 3, 4, right 1. Up 4, left 1 on the other side. And then from there, again, go up 1, 2, 3, 4 over 1. Up 4 over 1. It's going to be mirrored on both sides. We can fit one more. 1, 2, 3, 4 over 1. 4 over 1. So that is how I would do absolute value problems. I would not use the parent function points. You can use the parent function points. There's no reason why you wouldn't be able to, but I just think this way is much quicker. So what's kind of annoying about these problems, I'll be honest, is that there's kind of a different strategy for each type of function. So just to reiterate, what I would do for absolute value functions, I would plot the vertex and then count out the slopes. For cubic functions, I would use the parent function and transform from there. Same thing with square root. I would start with the parent function, which is this chart in green, and then transform from there. The step functions, I would just figure out how long are my steps and how far apart are my steps. This is another cubic, so start with the parent function, another absolute value, start with the vertex and go from there, the slopes. Okay, for quadratic functions, I would plot the vertex and then do 1A, 3A, 5A. That's how the strategy would go for that. And then finally, cube root functions, I would start with the parent function and transform from there. So hopefully that makes sense. That's one of every kind of problem. Feel free to pause, go back, review, and so on. And again, I apologize about the baby cries. Good luck, you guys. And I'm going to go over some of worksheet 3 in the next video.